All right, if you've ever worked with AWS Lambda, then you know what a pain managing dependencies can be. But don't worry, today we're going to solve all that by demystifying one of Lambda's most powerful features, layers.
So, does this sound familiar? You've written your function, it's great, but the deployment package is just huge. Uploads take forever, and you're starting to bump up against those pesky size limits. It is such a common headache, but hey, there's a fantastic solution.
Okay, so before we jump into the fix, let's just give the problem a name. We're going to call it the dependency dilemma, and it's really all about those common frustrations that pop up when you're deep in Lambda development.
You know, this is that cycle of frustration so many of us face. Your zip file gets way too big, and it slows down your whole development loop. You find yourself copying the same libraries into 10 different functions, so a single simple update suddenly becomes a huge chore. And you can just forget about making a quick tweak in the console editor. Your package is way too large for that.
But what if there was a way to just pull all of that shared, bulky code out of your functions package? Well, guess what? There is. So let's meet the hero of our story, AWS Lambda layers.
So what in the world is a layer? Well, at its core, it's really just another zip file. But instead of your function's logic, it holds all that extra stuff. You know, your library dependencies, maybe some configuration files, or even a whole custom runtime. It's the code that your function needs, but it isn't really part of its main job.
Okay, I absolutely love this analogy. Imagine your Lambda function is a chef. The function code itself, that's the recipe. The layer, that's a pre-stocked pantry. Instead of the chef having to bring all the flour, sugar, and spices every single time they cook, they just grab what they need from the pantry that's already there. It's just way more efficient, right?
And this just shows the difference perfectly. So over on the left, without layers, every single function package is self-contained, but it's bloated with all these duplicated dependencies. But on the right, with layers, look how slim the functions are. They only contain their unique code and then just point to a shared layer for all the common ingredients. And that means smaller packages and way less duplication.
Okay, this all sounds pretty great, but how do you actually do it? And the good news is it's a really straightforward three-step process.
First, you package your dependencies into a zip file, but it has to have a very specific structure. Second, you upload that zip to AWS, and that creates the layer resource. And finally, you just attach that layer to any of your functions that need it. Package, create, add. It's that simple. All right, let's really zoom in on that first step, package, because honestly, this is the most critical part to get right. It's not enough to just zip up your libraries. They have to be in a very specific folder structure for the Lambda runtime to find them.
So here's where the magic happens. When your function starts up, Lambda takes the contents of your layer's zip file, and it extracts everything into a directory named /opt right inside the execution environment. And that /opt directory, that's the spot where your function can find and use all those shared files.
So here's the absolute key. You have to create these exact directory paths inside your zip file. For a Python layer, for example, your dependencies have to live inside a python/lib/python3.x/site packages folder. For Node.js, it's node.js/node_modules. Each runtime looks for its libraries in a predefined path inside opt, and this table shows you exactly what that path needs to be. Get this right, and I promise you, everything just works.
Okay, so now that we know how to do it, let's cover a few of the must-know details that'll help you use layers like a pro. We'll look at some limits, how versioning works, and the tools you can use.
First up, you got to know about the 5-layer limit. You can attach a maximum of 5 layers to any single function, so you need to be a little strategic about how you group your dependencies together.
And second, there's that 250 megabyte total size limit. This is for the unzipped size of your function plus all of its layers combined. So layers really help you manage your packet size, but they don't give you, unlimited space.
Now, versioning is a really key concept here. When you update a layer, you don't actually change the existing one. Instead, Lambda creates a brand new version. Each one is what we call an immutable snapshot, and it gets its own unique ARN, which is just a fancy ID for that specific version. And this is just fantastic for stability and for tracking your changes.
And get this is a super important detail right from the docs. If you delete a layer version, let's say you delete version 2, any function that is already set up to use version 2 will just keep on working perfectly fine. You just won't be able to attach that deleted version to any new functions. This is a great feature because it prevents you from accidentally breaking your existing deployments.
Now, are layers always the right choice? Well, almost, but not quite.
They are absolutely fantastic for runtimes like Python, Node.js, and Java that get deployed as zip archives. But for languages like Go and Rust, the best practice is to just compile everything, your code, and all its dependencies, into a single executable binary. Using a layer in those cases can actually slow down your cold starts.
So, finally, how do you actually manage all this stuff? Well, you've got plenty of options that'll fit right into your workflow. You can click around in the AWS console, you can automate everything with the CLI, or you can define your layers as code for repeatable deployments with amazing tools like CloudFormation or SAM.
So let's just bring it all together. When you get down to it, why should you be using layers? Well, because they mean smaller packages, and that means faster deployments. They let you separate your core logic from your dependencies, share code so easily, and finally, use that console editor again. Really, it's all about making your development process way cleaner and so much more efficient.
Look, the benefits are super clear, and the process is actually pretty straightforward. So the real question I want to leave you with is this. Looking at your own projects right now, where can you start using layers to make your serverless applications cleaner, faster, and just plain easier to manage?